All right, folks, welcome back. All right, so okay, I see that people are joining, so we can get started. So welcome to module four, and this is, as you know, a 10 module course. We are in week 2 at the moment, right? And our focus today is networking services, and especially one of these VPC, virtual private cloud, right? So that's the focus today. But what we'll do is, I think this will be, although this is a difficult topic, right? It's a difficult topic for sure, based on my experience with other batches here at Edureka, but it'll be short, right? So I think we'll do this quickly, and today we'll have a bit of time at the end of this session for more Q&A, more questions and answers. Especially, we can cover topics from EC2 to S3, EBS, the stuff that we've seen thus far in this course, right? So that's the plan today. So first, we'll start with VPCs, and then we'll have some Q&A today. All right. Now on VPCs, right? Let me first start by showing you some of the VPC console a little bit. All right, so I'm going to show you the VPC console a little bit, right, and then we'll look at some slides, some conceptual content, and then I'll also show a demonstration of how to create your own VPC and how to set up your servers, how to deploy your servers inside of a virtual private cloud, right? Okay, now looking at the course so far, right, as you know, we've looked at EC2, which is part of the compute category of services. Yesterday, we looked at a bunch of storage services. So storage is a category of services, and then we looked at EBS, S3, right? Two very important services. We also looked at a little bit of Glacier, which is for long-term archival, and then a couple of services which are more important for enterprises, Storage Gateway and also Snowball, right? Today, of course, we'll look at networking, especially VPC, and we'll talk about one more service called Direct Connect, which is again more relevant for larger enterprises. This is more like a direct lease line connection between your public network and AWS, right? Okay, now a quick word about next week as well. So next week we'll do database services, and also in module 6 on Sunday we'll do load balancer and auto scaling, right? So databases are very important, right? So there are four different types of database services available. RDS, relational database service, where you can have your MySQL, Microsoft SQL Server, Oracle, the usual relational databases that we all are familiar with, right? But there's also three other services which are very interesting. These three other database services are DynamoDB, which is a NoSQL database service, and then Redshift, which is a data warehousing service, and also Elasticache, which is a cache in-memory cache service, right? So these outside of RDS, these other services, most people don't use them because it's hard to learn these technologies, hard to deploy, manage these technologies. But with AWS, these things become very simple, right? So even if you're a small company, you now have access to database technologies which in the past were only available to some of the larger companies, right? So this is a very important module, module 5, database services, right? You'll be able to look at these database technologies and see how to include them in your applications, right? Okay, module 6 also very important because this deals with load balancing and auto scaling groups, which are important for high availability, important for scalability, fault tolerance, right? And what is happening is in the modern world, in today's world, right? Every application needs to be up all the time, and it needs to perform fast, right? Because we are all now familiar with these internet services like Facebook, Google, Gmail, which are always up, which always work really well, and the expectation for everybody now is that our applications will also function in the same way. So that's why Module 6 is a very important topic as well. Right? So this is coming up next week, and today we look at VPCs, networking, and maybe a little bit of direct connect. All right. Okay. A quick recap of yesterday, where we looked at storage services, and especially we looked at EBS, which is block storage. And these are like hard disks. Conceptually, they are like hard disks, and they are accessible from the operating system, right? But they're actually network-based storage. It's a very important sort of feature or service within EC2. And we also saw within EBS the different storage, the volume types, SSD, HDD, magnetic. We also saw how to create snapshots, and from snapshots how to create volumes. The fact that EBS volumes are available only within a single availability zone, right? But you can attach these EBS volumes to a server. These volumes are independent of EC2 instances as well, so you can attach and detach. Right. So this is what we saw yesterday. We also looked at S3, which is essentially a true cloud-like storage service, because it's infinitely scalable. You can add any number of items into any number of objects into S3, and S3 also has a very high durability, 11 nines, right, and it also has very high availability uptime, which is 4 nines. And within S3 there are different storage classes. Infrequent access, for example, Glacier is also a storage class. There's also one type called reduced redundancy, and these storage classes and options are essentially different, are different services, different classes available at different price points, because they have they have a lower SLAs in certain characteristics. Right, so this is EBS and S3. We looked a little bit at Glacier, and especially we saw how to use the command line. Right, we saw the command line interface to Glacier, where you can upload your archives, and also how you can maybe initiate a job to download an archive. In S3, we also saw the lifecycle rules. Right, we saw the lifecycle rules where you can move objects from one storage class to another in a fully automated way. Right? And this helps with the administration of your storage very well. All right. So this was basically what we saw yesterday. Today, what we'll do is we look at virtual private cloud mainly, and a little bit of direct connect if we have time. Right. And a virtual private cloud is essentially a network. Right. It's a network. It's a private network. It's a private network, which means your IP addresses, for example, can be private. It's isolated from the internet, so it's not really connected to the internet, which means it is safer, I guess, right? So you're less vulnerable because you're simply not connected to the internet. Even if someone gets a hold of your IP address or gets a hold of your passwords or private keys, they just cannot reach your private cloud. Right, so it's safer in that sense. So AWS is basically reacting to the market demands, and as the cloud industry is maturing, right, they are looking for newer customers, newer industries, and this is probably the feedback that industries like banking industry, right, the financial services industry, or the healthcare industry has probably told them, look, your public cloud offering is not good enough for us. We need something better, we need something more secure, and that's why I think the VPC, right, the virtual private cloud offering is available. And I think AWS is realizing that this is a better way. Right? They're realizing that VPCs are a better way than pure public cloud hosting, and that's why they are nudging everybody towards VPCs. Right? So you'll find I think in some of the newer AWS accounts, you can only set up servers in VPCs, and also some of these servers, some of the EC2 instance types, for example, are only available within VPCs. So it looks like the direction is that VPCs will become the default way. Right? Everybody will have to use VPCs. Is what I sense is happening with AWS. All right. Okay. Now. The question is, we'll see this. We'll basically understand what is the VPC, what are its benefits, and it's a complex, it's a little, difficult topic because many of these concepts and components that are part of the VPC are probably new. They're probably new to you folk. It was new to me as well, right? I was not a networking person at all. I've been in the technology industry for a long while, but I never dealt with networking stuff, right? I dealt with applications, databases, maybe some system administration, but not really network administration, right? So that's why it's a little bit of a difficult topic, but we all have to learn it because this is going to be the default way, right? This is we all have to set up servers within VPCs in the future. All right. So what is a VPC? What are its benefits? What are the different components of VPCs? We'll have to understand this a little bit, and we'll also talk about some common scenarios of VPCs. So there are 4 common scenarios. 2 are general, and 2 are for enterprises, and these scenarios basically talk about how do we set up our servers. Maybe some servers are public. How do we set those up? And some parts of your stack may be private. How do we set those up in our VPC? Right. So this is what we'll talk about today. All right. Now, before we get into this, right, what I wanted to do was I wanted to show you a little bit of the VPC console, just to orient you to this, and then we'll talk about some of these concepts here. All right. Now, if you look at the home page of your AWS console, just scroll down to the networking section here, and you can see this link here, VPC, Virtual Private Cloud. This is the first service in the networking category. All right. Now, let's look at the menu options here, right? So you can see here there's VPC, which is basically you can have many VPCs. You can have many VPCs. Each VPC is a private network, right? It's a private network, and it's called a virtual private cloud because it's going by the strictest definition of a private cloud, right? A private cloud is something where you have you as a company, right, or as an organization has control, has ownership, right? And it usually refers to infrastructure which is in your own data center, right? But this really is not owned by us as users, right? It's not fully under our control. It's owned by AWS. It's under AWS's control, but it has other characteristics of a private cloud, right? That's why it's called virtual private cloud. It's not a full private cloud. It's a virtual private cloud. All right. So you'll have VPCs. You can have many. This is one VPC. It's a one private network. You can have more such private networks, right? And these are, private networks are basically, these are a set of IP addresses, right? A network can be of different classes, of different sizes. And within this network, you can set up your resources, which could be EC2 instances, RDS instances, etc. Right? You can have many such VPCs. Now, a VPC consists of one or more sub networks, right? So these are sub networks which you can create within a VPC. So this this VPC, by the way, is called a default VPC. If you go into the VPC console with your account, you'll find there is one VPC already set up. This is called default VPC, right? And the default VPC will have one subnet per availability zone, right? So this region, the US East 1 region, North Virginia, has 4 availability zones. That's why you see 4 subnets here, right? So each is a subnetwork within the larger larger VPC network. Right, and each subnetwork, each subnet has what's called a routing table. This is a table which determines how the network packets will flow within the VPC, and also between the subnet and the outside world. Right, so we'll talk about this. We'll talk about what a route table is, what these rules mean. Right, I'm just trying to orient you towards the VPC, and then in the slides, hopefully you'll be able to better follow this. So each subnet must have a route table, and the route table sort of decides or governs how the traffic flows within the VPC and between the VPC and the outside world. All right, and a subnet or the VPC also has something called a network ACL, NACL, right? Network Access Control List, and this is a firewall, right? It's a network level firewall, independent of the security group that we've been using so far in the course, right? So we've seen, we have attached. We have a security group with EC2 instances, right? We've seen how to set up those firewall rules there. But in addition to the security group, you also have a network level firewall called network ACL, right? So these are some important components here. There's also some components like internet gateway. So this is a component which, when attached to a subnet via the route table, makes the subnet a public subnet, which means a subnet can be accessible from the internet, right? You can access some parts of your VPC from the internet, provided there is an internet gateway associated with that subnet, right? So this is something you'll have to understand. There's also something called NAT gateway. This is essentially a managed service which allows private subnets to go out to the internet only on the outbound side for things like software patches, right? So this is something you have to understand as well, right? Okay, so basically, you have virtual private clouds. These are networks, private networks. The VPC, you can have multiple VPCs. Each VPC can consist of will be made of one or more sub networks, right? Each subnet will have a routing table. Each subnet will have a network firewall, right? Internet gateways help you convert a subnet into a public subnet, which means it can be accessible from the internet, from the outside world, right? And then there are NAT gateways, which are for outbound access from private subnets, right? All right. There's more. There's more stuff. For example, peering. Right? Peering. You can create two networks. Right? You may have two VPCs, and you may want them to communicate with each other. Right? Normally, a VPC is a private network. It's hard to connect to it from the outside the network, right? But if you have two VPCs and you want to make them talk, you can create a peering connection between two VPCs, right? And you can also create a peering connection between VPCs that belong to two separate AWS accounts as well, right? For example, you may have two accounts, one for live servers, one for test environments, and you can then you can peer the two VPCs in these two AWS accounts. All right. Okay. Now, one more thing is there's also VPN connections, right? VPN connections. So here, what you can do is some of the VPCs are they're not meant for public use, right? You don't need anybody to connect to it except your own employees, right, from your own corporate network. So in that case, what you can do is you can have your servers in the VPC, and then you can connect to the VPC using a VPN connection, right? So this is a private encrypted connection from your corporate network to the virtual private cloud, right? So it's a very safe way. You have the benefits of cloud, but the full privacy and full encryption of a private, as if it's in your own, as if the VPC resources are in your own network. All right. Okay. So this is a quick overview of VPCs from the web console, right? So that you have some visual understanding of what a VPC is. Now let's look at the slides a little bit. All right. So first of all, right, we saw that VPC is a private network, and it consists of one or more sub networks. Right, you can create many sub networks as long as you don't exceed the VPC network size. Right, and it's basically like it says here on the slide, a portion of the network, these are, if you have two subnets, right, they'll have a different IP address range. For example, in my home, I have two subnetworks in my home network. One is 192.168.0.x, right, and the other subnetwork is 192.168.1.x, right. So this is, you've probably seen it at your homes, at your workplaces. So in the same way, you'll have subnets within VPCs. All right. Now, each subnet will have its own IP address range, right? So you may have something like, say, 10.0.0.0/24, right? /24. This is called CIDR notation, right? And I'll show you a Wikipedia page, which is very informative. You can review that later. But basically, each subnet will have an address range, and the address range will have a subnet mask, right? And that mask determines the size and the IP addresses of that network, right? Now, these are networking concepts. You can look these up, but what I suggest is at a high level, it's very simple to understand. Let me show you this page here. This is the CIDR page on Wikipedia, and you can go down, you can scroll down to this table here where it talks about the various IPv4 CIDR blocks, right? So this, if you look at, for example, this address here with a /16 in the end, right? A.b.0.0/16. The /16 refers to a subnet mask of 255.255.0.0, right? And you can look up, these are networking this is not an AWS specific thing, right? It's just general networking information. But broadly, what it means, is this is a network which can have about 65,000 IP addresses, right? In the same way, if you have a subnet mask of /24, this means it has a subnet mask of 255.255.255.0, and this subnet will have 256 IP addresses, right? So this is, we need to understand these things because you will see this when you create subnets and VPCs, right? So just make sure that you understand that that there's a CIDR format of CIDR notation of these IP address ranges, right? And the notation consists of an IP address like this one, ABCD or ABC.0, and then there's a subnet mask at the end of it, right? And the subnet mask basically determines the size of the subnet or the VPC, right? So this is how it works, and this this explains. This is a good slide. It tells you that there are different types of network, different sizes of networks, and the subnet mask determines the size of your network. So class A networks have a subnet mask of /16, right? I'm sorry, class B networks have a subnet mask of /16, right, which translates to 255.255.0.0, right? And this has about 65,000 IP addresses. So the VPCs we create in AWS will be class B networks, right? And the subnet that we create, inside the VPC, we'll have a subnet mask of /24, right? /24, and these will be C-type class C networks, right? So the subnet mask will be 3 255s and 0, and this will translate to 256 IP addresses, right? So just remember that we are using class B networks for VPCs, and we're using class C networks for subnets, and the VPC will have about 65,000 IP addresses, and the subnet will have 256 IP addresses, right? So that's all you need to know at this time. All right, now let's look at the VPC at a conceptual level. What it is it's basically a private network, right? It's a private network, which means it's not connected to the internet in general, right? In general, it is not connected to the internet. You may choose to connect it to the internet, right? You may choose to do that, but in general, a VPC is an isolated network, right? It's a private network, much like your home network or your corporate network, right? Okay, so that's the VPC. Now, within a VPC, you can launch your EC2 instances, RDS instances, and other type of AWS resources. So that's what you do. The reason we are looking at VPC is because we want to create our servers and our resources inside of the VPC, right? So you have these instances, and the VPC will also have will have subnets. The subnet is actually created at an availability zone level, right? So the VPC is at a region level, and inside the VPC you have subnets, and a subnet is only at a zone level. Right, so one subnet can only span one zone. It can't go beyond that, and the VPC can only span one region. It cannot go beyond that. Right, now, optionally, you can connect what is called this internet gateway. You can connect an internet gateway to the VPC, and using the internet gateway, you can make it. You can connect the VPC to the internet. Right? So you can have the VPC accessible from the internet using an internet gateway. Right? If you don't have the internet gateway, there's no way you can connect from the internet to the VPC. It remains an isolated private network. All right, and it's also possible to create a VPN connection. Right? It's possible to create a VPN connection from your corporate network to the VPC, where the VPN connection makes it an end-to-end. There's an end-to-end encryption. Right? There's an encryption when the traffic is passing over the public internet, right? That traffic is, those network packets are encrypted, so you have a very secure channel connecting from your corporate network to the VPC, right? So this is how you can use VPCs. This is you can understand it's larger companies, regulated industries, banking, healthcare. These sorts of companies will probably appreciate, right? They'll appreciate that VPCs is something that we can work with, right? Without VPCs, they probably would not move to the cloud. All right. So what we do here is, in a VPC, you can launch your instances in a subnet, right? They are launched in a subnet in a particular availability zone. Each subnet can have you can customize your IP address ranges, right? You have full flexibility. It's almost like your own network, so you can decide what kind of IP addresses you want, what kind of how many subnets you want, right? Whether they're public or not. All those things can be controlled. You can create routing tables, right? We saw a little bit of routing tables in the web console as well. These are tables which are associated with the subnet. Each subnet must have a route table, and this governs how the network, how the servers in that subnet can communicate with the rest of the VPC and with the outside world. Internet gateways are for converting, are for making VPCs accessible from the internet in both directions, right? So this is important. You can have two firewalls, right? So this is important as well. In a VPC, you have the usual security groups, right? Which are you can create a security group for your web servers, another one for your application servers, another one for your database servers, right? But in addition to that, you also have the ACL, the access control list. This is something we saw in the management console as well, right? And this is a network level firewall, network ACL. So there are two layers of firewalls in a VPC, right? Which is again a good thing from a security point of view. And of course, you can connect to the VPC using the VPN, right? This is what we saw in the previous slide as well. All right. Now let's let's look at the implementation aspects, right? Let's look at how do we use VPCs right? And let's also try and understand the various parts of the VPC, because after that we'll be able to implement a VPC, maybe deploy a server inside of a VPC, and then also connect to it, right? So let's understand some of the implementation aspects. Okay, so first of all, there is something called a default VPC, which is what I showed you right at the start of the class, right? And this default VPC is pre-created, right? It's a ready-made VPC which is available by default in all AWS accounts. Right? So you can go to any region. In each region, there will be one default VPC, right? And it looks like the reason AWS has created this default VPC is to make it easy for people to get started with using AWS. Right? So when you want to launch an EC2 instance, you may need a VPC, right? So there should be something readily available in which you can launch your EC2 instances. This is when you're learning. This is when you're testing stuff, right? You need something which is already available, so that the barrier of using AWS resources is not too high, right? So that's what a default VPC is. It's meant for it's a convenience, right? It's a convenience. It's easy to use because the firewall rules and the routing etc. is open, right? It's very permissive. Firewalls, for example, are open. You can access most of the ports. Effectively, the firewalls are not working, right? So the point I'm trying to make is the default VPC is there for your convenience, right? It's easy to get started with the default VPC. It's easy to use. Things tend to work, right? If you set up some EC2 instances in the default VPC, you'll be able to use them well. You'll be able to connect to the EC2 instances easily because the default VPC has loose rules. Right? The rules are very permissive, they're very open, and therefore, right? Therefore, you must not use the default VPC for serious stuff. Right? Don't use it for your production environments at all. Right? It's only a convenience. Right? It helps you get started quickly, but don't use it for production environments. You have to create your own VPCs with your own configuration, with your own network ACL settings, with your own security groups, right? So all that has to be done separately for your production or live servers, right? So that's what it is. This table, this slide here explains the difference between default and non-default. But the main thing is the default is a convenience, right? You can use it when you're learning AWS, but don't use it for live servers. All right. Okay. So this is a quick point about default and non-default. Now security groups. Right? Security groups are something we have used before with EC2 instances, for example. Right? And the same security groups are available inside of a VPC as well. Right? So you don't change how you launch EC2 instances, how you set up your security group settings when you're launching EC2 instances. Those things don't change, right? So they are still there even though you'll be using VPCs. All right. Now these are some of the key components. Right? You need to understand each of these components if you want to use VPCs successfully. Right. So within a VPC, you have to understand IP addressing. So there's private IP addresses, there's public IP addresses. You can use elastic IP addresses as well. Right. So the same things that we've seen before with EC2 instances are also possible inside of a VPC. Right, private, public, and elastic, and most of the communication between servers inside of VPC will happen using private IP addresses. Right? There's no need to use public because public IP addresses you have to go out to the internet. Right? Private IP addresses are fine for communication within a VPC. However, if you need people to connect to your servers from the outside, then you may need to use public IPs or elastic IP addresses. Right? So this is something we'll try and understand. You need to understand the difference between public and private subnets. right? And the main difference is public subnets are accessible from the internet, private are not, right? Private subnets are not. You cannot connect to any server if it is inside a private subnet, right? You can't connect to it from the internet. You can't connect to it. For example, I cannot connect to something in a private subnet from my home network, right? That would not be possible. Whereas I could connect to a server if it sits inside a public subnet. All right. Okay. Route tables. We've seen this before. You associate route tables with subnets, and the route tables determine the routing, right? The network routing of that subnet. How does the network, what is accessible from that subnet in terms of outside the internet or other subnets within the VPC? Access control list is a firewall, right? A network level firewall, the second layer in addition to the security group. NAT gateway is something which is used. It's a network address translator. It's used for outbound connections from the private subnet. Peering, we saw a little bit of peering. This is to connect two VPCs, right? These are two private networks which may need a connection, right? So you need to set up a peering connection between the two VPCs. And then you have the internet gateway, which is used to make a subnet into a public subnet, and you also have a virtual gateway, which is for VPN connections. Right? So there's a bunch of stuff within a VPC that you need to understand, and let's do that a little bit now. All right. So this is, I think, easy to understand. Private IP addresses are not reachable over the internet. These are private, right? These are private IP addresses for use within the VPC only. The public IP addresses you may have by default within VPCs. You don't have public IP addresses, right? Because it's meant to be a private network. So by default, your EC2 instances will not have public IP addresses. However, you can choose to have public IP addresses in some cases, especially servers, for example, web servers, which need to be accessible to the internet, right? So you can optionally create public IP addresses. All right, subnets can be private or public, right? Public subnet is one where you may have, public-facing, internet-facing resources. For example, web servers, right? So your web servers will sit in the public subnet so that they are available to the outside world via the internet, right? And the private subnet is private. You can't access anything inside the private subnet from the internet, right? And that's a good thing. That's a good thing because your application servers, your database servers, these types of components can sit in the private network where they are safer, right? Where they are safer. All right. Okay. Now the internet gateway is the component which converts a subnet into a public subnet, right? So if you find an internet gateway in the route table of a subnet, that would mean that that subnet is a public subnet, right? So it's very simple. If there's an internet gateway, it's a public subnet. If not, it's a private subnet. All right, a route table. We've seen this. It's a set of rules, right? There's a set of routing rules in a table, and a route table is associated with a subnet, right? It's associated with a subnet, and this governs the network flow, the flow to and from the subnet. Right? And we'll try and understand. We'll look at the routing rules, and we'll understand each one of those rules to see what it means. All right, an ACL, right? A network ACL. This is a different. It's a firewall, right? It's a firewall. It's an additional firewall, and also, it works a little bit differently. It works differently from the security group. For example, here the rules are in an order, right? The rules are specified in an order, and the rules are evaluated from the lowest to the highest rule number. And if there's a match, no further rules are evaluated, right? And also in an ACL, you can set up separate inbound and outbound rules. So this ACL is in a way, a more powerful firewall. It's a more powerful firewall than security groups, right? And often you basically have to configure both firewalls. All right. Now a NAT, right? A network address translation is often used by the private subnet, right? by the private subnet. For example, you may have a database server in your private subnet, right? So the way it works is you need a NAT gateway or a NAT server or a NAT instance for allowing access from the private subnet to the outside world, to the internet, but only on the outbound side, right? Only on the outbound side, because you may need to install patches for your database server, right? So for those purposes, you need a NAT gateway or a NAT instance to be set up inside of your PC. Right? So we'll take a look at this as well when we implement our VPC. All right, let me skip this. There are two options in the NAT. There's a gateway option and an instance option. I think you should always use NAT gateway because it's simply a managed service. You don't have to deal with the overhead of managing a NAT instance, right? So just go with the NAT gateway. It's a better option. All right, peering, right? This is VPC peering, and this allows you to connect two VPCs, two private clouds or two private networks. And these two private networks can be in different AWS accounts as well. All right, and the internet gateway, we've talked about this. It's basically a component which is required for outside connections. So this can convert a subnet into a public subnet, and this makes it possible for you to access the subnet from the internet. All right. Okay. So I think we've seen a lot, right? It's a lot of probably new terms, right? A lot of new terms. A lot of new concepts. So let me stop here and let's maybe do some Q&A, and then I'm going to show you these things which will I think help you understand better, right? But what I'm going to talk about or show you is maybe one or two of these scenarios. These are 4 common scenarios, right? And AWS has lots of documentation on these scenarios, and we'll talk about these scenarios first, and then I'll show you maybe 1 or 2 of these VPC scenarios. Right? So the scenarios will explain to you how you can create your application, right, inside of a VPC. So that's what these are. All right. Let me stop here. Let's see if you have any questions. We use the same sheet, right? We use the same sheet. This is week 2, storage and networks. If you don't have access to this document, please let me know. I'll send it to you. All right. Okay. So the first question here is from Ratish. Ratish, what you're saying is, does Amazon give the IP addresses also by default? Yes. So when you create, right, especially when you create the VPCs using a wizard, right? You can use a wizard, by the way. There's a helpful automated tool called the VPC wizard, and you can use that. And so when you create a VPC, right, you can use the wizard, and use the wizard. Basically makes it very easy, right? It makes it easy to create your VPCs, and the wizard also gives you some default IP addresses, right? These are, by the way, these are private IP addresses. So there's no conflict. You may have the same IP addresses used in multiple VPCs, but because they're isolated networks, there's no conflict, right? So the wizard may have default IP addresses. May have default IP addresses. You can change them, right? You can change these IP addresses if you like. You can change these if you like, right? Or you can retain them. So the answer is yes and no to your question, right? You can, it does give you something default. You can use what they're saying in the wizard, or you can change that and set up your own. You can set up your own IP addresses, right? So this we'll see this. When you see this, I think it will become clearer. And sometimes, and these are private IP addresses, right? These are private IP addresses. Sometimes you need public, right? Sometimes you need public IP addresses or elastic IP addresses as well sometimes. So those also. So here, especially with these, you don't have control. Right? You don't have control. You can't say you want a certain IP address, right? You can't do that with the public ones. You can't say you want a certain IP address here. right? So not with public or elastic, but with private, you have control. You can decide what your IP addresses should be. All right. Okay. Greg, what networking features does AWS charge for? Yeah. So the question is, VPCs are fine, right? VPCs are fine. They have seem to have better security, better firewalls, right? But is there a cost? Is there a cost to using VPCs? And the answer is no, right? No cost. No cost. You only pay for you pay, however, for EC2 instances, maybe RDS instances, any resource that you set up within a VPC, right? So you pay for these things, but not for the VPC itself. Now there are certain components, by the way. For example, the NAT gateway, right? The NAT gateway is a paid component. Right. So there could be some elements which are optional, right? You don't have to use these, but if you use these, then there is a cost. So so there may be a cost for this NAT gateway as an example, but I don't see. Let's let me just, because these things keep changing. So let me just go back and look at this as well. I think it's an important question. It's right here, right on the home page in Google. You can see, for a VPN connection, there seems to be a payment, right? There seems to be a per hour price for a VPN connection. But let's look at other aspects as well. All right. So there seems to be, for VPN. There's definitely a price for the NAT gateway if you choose to use it, right? Both are optional, right? Both are optional features. So you don't need to use a VPN connection, but if you do, there's a cost. You don't need to use a NAT gateway. If you do, there's a cost, right? So the NAT gateway has an hourly price plus some cost for the data that is processed by the NAT gateway, right? So I think that's it. I think these are the only two items, right? Otherwise, VPC is free. So you can create your VPC subnets, your ACLs, all those things are free. But looks like VPN and NAT gateway, right? These are paid. So however, let me just edit this answer. However, two optional components, which is one is the NAT gateway and the other is VPN connection. These have a price. All right. Next question from Greg is: do enterprises typically set up a WAN link directly to AWS, right, or is all AWS accessed via the internet using VPN? So, so there is, I think most enterprises, right, especially the smaller ones, I think most people use the internet, right? Use the internet plus VPN. VPN is for the security, for the encryption, and they use their existing internet connections to connect to the AWS cloud, right? And especially this is fine, right? Especially this is fine if you're just creating servers and setting up your applications on the cloud. And all you need is, on a day-to-day basis, you're not transferring too much of data, right? You're just connecting to the servers, maybe over SSH. SSH is very light on the networking side, right? So you don't really need anything more than that, right? So most people would set up some servers, right, and manage those servers from their network. There isn't too much of network data transfer, right? So internet plus VPN is sufficient, right? Internet plus VPN is sufficient. However, some of the larger companies, right, probably, especially if you have something like hybrid cloud, right, larger companies with maybe hybrid cloud type of requirements, right? Where there's constant, upload and download of lots of data, right? Where lots of data is moved up or down, may need something dedicated, right? They need something dedicated. So there is a service, by the way, called AWS has a service called Direct Connect, right? It's sort of a, they have these termination points in various cities, right? Not all cities, but I think some of the major cities, and you can then have a sort of a leased line, sort of a direct connection to that termination point in your city, and then that way you have a dedicated connection with a consistent, which will give you consistent network performance, right? And it can also reduce your network cost. It can speed up your data transfer. So I think in some cases it makes sense, but my guess is there will be very, very few companies which do this. Like most people will use the internet with the VPN. All right, Ratish, this is perhaps a more generic question. Is there any way we can ourselves measure the amount of data transferred? Well, I'm not, there could be some tools, right? There could be some tools that you can install. So I'm not very familiar with this area, right? But there could be some network tools that you can install, right? That you can install somewhere. Yeah, but the question is, you have to pass all your traffic through that tool, right? So maybe you can do it at a local level, right? Maybe you can install that tool on a server and then measure the outgoing and incoming from that server, right? And compare it to what AWS is saying you are using, right? So there could be some ways in which you can do it, right? If you really wanted to, right? So there could be some network tools that you can install and measure. And you can easily compare, by the way, because your bill, right? Your bill tells you exactly how much data, right? So your bill tells you lots of details about network traffic, right? So you can compare by measuring it yourself. You can compare your measurements, right? And also CloudWatch, by the way, right? CloudWatch is a monitoring tool, can also give you information, but this is from an AWS point of view, right? This is only so that you can compare your own measurements with what AWS is saying. All right. Okay. Now this question here, Greg. This is more about so far we're looking at AWS as individuals, right? We all have our own accounts. We're creating one or two servers here, but Greg's question here is about larger companies where there could be literally hundreds of servers, and also you also have typically in these larger companies lots of people accessing the same AWS account, right? And you want to be able to sort of manage the permissions, right? So that's what the question is about. And in terms of view, right? In terms of view, I think it's pretty basic, right? So at this moment, it's pretty basic. For example, if you were to look at EC2, what you can do, I think, the way you can filter these, right, is what is called tags, right? You can use tags to filter some of these resources. So when you launch an instance, for example, right, when you launch an instance, one of the things you can do with all the AWS resources, right, is you can attach some tags, right? So these are tags available for all resources: EC2, RDS, S3, EMR, DynamoDB, everything, right? So all resources can have tags, and you can use something like this. For example, let's say department, right? Let's say this is I don't know, marketing department, right? So something like this, or there could be another tag which is, say, cost center, right? Which is say A001. So you can create tags, which is a very flexible, very good way of adding some metadata to your resources, right? So this is what you can do. A lot of people, I think, do this in a very systematic way, right? So this is something to consider, and then you can then filter by those tags, right? So from a view perspective, I think this is what is available from a organization of the view, right? However, AWS is very good with permissions, right? It's very good with permissions. So what you do is you have to use something called IAM. This is identity and management, identity and access management, right? Access management. So here, what you do is you create, you can create users, groups of users, and and then permissions, right? And the permissions for these users or groups of users, right? And the permissions are very granular, right? So these permissions can be granular in terms of what resources are to be accessed, right? What actions can be performed, and also, some conditions can be added. For example, the source IP address should be so and so to allow connectivity. The resources may have certain tags, only then access should be allowed. So lots of options are available. Lots of options. So this IAM is a very powerful, very powerful tool. I think all your needs, right, in terms of controlling access will be met using IAM, right? So that's the way to do it. Let me also write here a little bit about tags. Tags are a way to organize, right? So you can organize your resources using tags, and these tags can be used in IAM, by the way, right? So you can use these tags to allow access or disallow access in your IAM policies, and these tags can be used in IAM policies. They can be used in your billing reports for cost allocation, right? Lots of stuff can be done. So yeah, so these are some of the ideas that you can consider for this. And also, there are some other services which are better, which are meant for for maybe enterprises. So, for example, there's something called CloudTrail. Right? CloudTrail is an audit trail of user activity. Every single activity performed by any user is tracked in CloudTrail. Right? So this is one more tool for you. A service catalog is another tool where your organization can create a catalog of approved services. Right? This is something that happens in larger enterprises where you may say, look, okay, you are allowed to buy this type of server, right, or this type of storage. So those kinds of things, what is approved, what is not, can be maintained in the service catalog. Right? So there are some management tools which you might find useful from an enterprise point of view. All right. All right. So Ratish, so we create a private network and configure some gateways to connect to the public network. All right, so this is really a question on the cost, right? It's a question on the cost, and the question is, we will end up paying something because to connect to it, we need to use something that is a paid component, right? So I think not, right? I think not. Look, first of all, in my view, AWS is a very fair organization, right? I'll tell you that from very long experience. There's nothing sort of underhanded, right, or that bait and switch. There's nothing like that here, right? So it's not like they're saying VPC is free and then on the sly trying to charge you for something, right? So that's not the case here. And what happens is VPN is optional, right? VPN is optional. You don't have to use it. You can connect to your VPC without a VPN, by the way, right? And I'll show you that today. So VPN is optional, which is a paid service. And the NAT gateway, right? NAT gateway is also optional. You don't need this. You don't need this strictly, right? There are ways of getting around this. So both are really optional. But if you and if you use the NAT gateway, there's a smallish charge, right? There's a smallish charge. So so you can, for example, create a VPC which has a public subnet. By the way, internet gateway, what you mentioned here in the question, the internet gateway is not a paid component, right? It's not a paid component. So you need the internet gateway to make a subnet into a public subnet, right? So so with using an internet gateway, you can connect to the VPC from the internet, right? Which is what you want. So this is not a paid component. Right, and the general comment also is AWS is very fair, right? It's very fair. You know, you can see prices are transparent. Prices are very low, right? They're very low, and also prices are dropped frequently, and that's how they operate, right? So it's you know, I think they're not they're in a state of expansion, right, where they want to look at reducing prices. They're not really looking at profitability at the moment. Is my thought. Just like Amazon.com, by the way, right? So all right, okay, so. So I think we are ready, right? We are ready to look at some of the implementation aspects of the VPC, right? Let me show you talk a little bit about these 4 scenarios, and then I'll show you the implementation of maybe 1 or 2 of these, right? So what you can do is you can just look for AWS VPC scenarios. Just do a Google for this, and you'll have this documentation, right? So these are the 4 scenarios. Let's take a look at these visually, right? Let's look at these pictures here, and this is scenario 1, where you have a VPC with 1 subnet, right? There's 1 subnet, this one here on the top, and this happens to be a public subnet. It's a public subnet, and you can see there's an internet gateway, right? This is the one that makes it a public subnet, and the gateway is associated with the subnet using the route table. You can see there's an entry of the internet gateway. There's a routing rule which has the internet gateway as the target, right? So this makes this subnet a public subnet, which means you can connect to this EC2 instance in the subnet from the internet, the same way that we've been doing thus far, right? So this is very similar to using an EC2 instance outside of a VPC. Okay, so this is scenario 1, very simple. And what's the use case, right? You may ask, you know, where will we use this, right? So the answer is if you have a web application, right? Maybe a website or a simple web application, then the web server, right? This may be a single instance on which your entire application is running, and this instance will have a web server, right? So that needs to be accessible from the internet to your customers, maybe. So then that EC2 instance will sit in the public subnet, right? Because it needs to be accessed by people from the internet, right? So the use case is simple web servers, web applications, anything which needs to be accessible to the public from the public internet. Right? This is scenario 1, very simple, very simple. Scenario 2 is a little more advanced, and here what you have is you have 2 subnets. The first one is a public subnet, and the second one is private. Right? And the internet gateway is associated with the public subnet, right? Therefore, it's a public subnet, and the private subnet. And by the way, the web server is in the public subnet, as you might expect, and the database server, this is a web application, let us say it has a database server. The database server should sit in the private subnet. It never makes sense to have these things in the public subnet, right? In fact, you must have everything in the private subnet, and then only the public facing, only the internet facing components need to be in the public subnet. Right? So this is how you set it up. and you can see in this VPC there's also a NAT gateway which is used by the private subnet to go out for patches and stuff like that, right? And because the NAT gateway needs to connect to the internet, it sits in the public subnet. However, it is used exclusively by the private subnet, right? So, so even though it sits in the public subnet, it's actually meant for the private subnet, right? So these are these are two common scenarios where this is very common, I guess, right? Maybe scenario 2 is more common because you have a web application with some components in the private subnet, some components in the public subnet. Right, so this is a good one, and then you have scenario 3 and 4. 3 and 4, these are very similar to 1 and 2, except there's a VPN connection, right? So these are for applications where you want to access the applications from your network. Maybe these are internal applications, right? Your HR application, your financial application, and you don't need public access for these, maybe, right? You only need to access them from your corporate network. So just set up your VPC and create a VPN connection, and your users, your employees in the company can access these applications. Right, so this is very similar to scenario 2 actually, with only the difference being the VPN connection. All right, and scenario 4 is quite similar. It's quite similar to scenario 1, right? But again, it's only meant for access from your company network. Therefore, there's a VPN connection. Right. So we'll only talk about 1 and 2 because 3 and 4 are very similar. 3 and 4 are similar to 1 and 2, with the exception of the VPN connection, which is out of scope as far as this class is concerned, right? But we'll look at scenarios 1 and 2. All right. Okay. So let me start with scenario 1. I will implement this, during this class, right? I'll implement this VPC, and I'll also create a EC2 instance. We'll probably install a web server on this. We'll connect to this using SSH, and we'll also connect to it over HTTP. Right. So let's take a look at this. We'll implement this end to end so that you have a good understanding of the various parts of the VPC and what needs to be done to create a public a VPC with a public subnet. All right. Okay. So let's get going. Let me create the scenario 1 VPC, and what we'll do, by the way, is we'll use the VPC wizard. Right. So if you are in the home page of the VPC dashboard, right, you'll see this button here, Start VPC Wizard. Right. And this button is not available anywhere else. Right. You won't find this anywhere else. So you might be wondering where it is. So just go to the main page. Just go to the main page and find this wizard, right? And my recommendation to you is always use the wizard. And always use the wizard because it simplifies. It automates a lot of these steps, right? If you try to create your VPC manually, then you can do that. However, you should be an expert, right? Because there's a lot of different components. They need to be connected to each other. They need to be configured. So you may make a mistake, right? You may lose a lot of time trying to troubleshoot your way through, right? So don't try and create anything manually, even though you can, right? You can come here and say create a VPC. You can come here and say create a subnet. You can do that manually, right? You can create a VPC by hand. But initially, at least, my recommendation is that you should always use the wizard. All right, and in the wizard, you have those 4 scenarios, right? So these are the most common scenarios. Most likely, you don't need anything more than these, right? You probably will be able to fit your application in one of these 4 scenarios. So there's no need to really do anything by hand. Right? Okay, so this is the VPC wizard, and you can see the 4 scenarios are available as options in the wizard, right? And we are interested in creating the scenario 1 first, right? So let me select this, and let's move forward. All right, the wizard makes it very easy, right? There's only a few things you need to specify. For example, maybe the name. right? This is the name of the VPC. So I'm just going to call it scenario 1 here, and you can see everything else is filled by default. You don't have to change it, right? And the IP address range of the VPC is specified. The IP address range of the public subnet in the VPC is specified as well, right? You don't have to change it, but you can if you like. And remember, this is /16. The network mask is /16, which means it has about 65,000 IP addresses, right? And the subnet has a network mask of /24, which means this has about 256 IP addresses, right? Some of these are reserved, by the way, right? They're reserved for some DNS services and things like that. So that's why you have less than less than the whole network. But broadly, 65,000 IP addresses at the network level, 256 IP addresses at the subnet level. Right? Okay, that's it. We just have to specify the name and go with the default settings and click on Create VPC. Right? Very, very simple. Very simple. So it will do a lot of work. It will create your VPC, your subnet, your routing table, your ACL. Lots of things are created as part of this wizard's launch. Right? So if you look at your VPCs, you'll now find there are two. Right? This one, the one on the top, is the default VPC. Right? By the way, folks, just make sure that you don't delete this VPC. Right? It's possible to delete the default VPC, but don't do it. Right? Don't do it, because it becomes a little complicated to get it back. And if you don't have a default VPC, then when you're practicing, you'll find some difficulties. Right? So make sure that you don't delete the default VPC or any of its components. Right? Be very careful about that. All right. So we have two VPCs. Right? The one at the bottom is the scenario 1 VPC that we just created. All right. Okay. The VPC is at a regional level, right? It's at a region level, and within the VPC, you'll find subnets which are at the availability zone level, right? So if you look at the subnets, there are now 5 subnets. 4 belong to the default VPC, and this one here is the one that we just created. This belongs to the scenario 1 VPC. Right, and you can see the IP address ranges are different, right? In the default VPC, you have 172.30.10.20.30, right? So these are the IP addresses in the default VPC. In this one, we have 10.0.0.0/24, right? You could have the same IP addresses, by the way, right? Two VPCs can have the same IP addresses because these are private networks. They don't talk to each other. There's no IP address conflict, right? So it's possible to have VPCs with the same IP address ranges. All right. Okay. Now this public subnet, right? A subnet is only at an availability zone level, right? So you can see here, this public subnet is in 1D, and it's in 1D. So when you launch your instances in this subnet, you're essentially launching them in this zone, in the 1D zone. All right. Okay. Now, looking at the subnet, right, there are different tabs here. So let's look at the route table. This is the route table, and you can see here this has 2 rules. Right? This rule, the first one, has a target of local, which simply means that the communication between different subnets, right, or within the subnet is allowed, right? So all the traffic within the VPC, right, between subnets within the subnet can flow freely, right? That's what this rule means. This is called the local rule, right? And then the second rule refers to an IP address of 10.0.0.0/0, right? This is external IP addresses. This refers to external IP addresses, and the target for this for these IP addresses is the internet gateway, right? And this means the presence of this internet gateway here means that this subnet is a public subnet, right? The internet gateway allows for bidirectional access. So you can connect to the subnet from the internet, and also the subnet can connect to the internet from the inside, right? So it's bidirectional, and this is possible using the internet gateway, right? If you were to edit this and remove the internet gateway, right? Then the public subnet would become a private. All right, folks. Let me just let me give me a second. Let me get a hold of my multi-factor app here. All right, so I use MFA, right? And we'll talk about this. You must set up multi-factor authentication on your AWS account as well. So we'll discuss this in an upcoming module. All right, so we were looking at the public subnet, right? And we were looking at the route table and the fact that this has two rules. One of them talks about the internet gateway. This is what makes the subnet a public subnet, right? So you could, perhaps you can maybe delete this, right? Maybe you can delete this. All right, I'm not sure how to delete this. Okay, I think we'll have to go to the route table and delete, but you can potentially delete this rule, right? And if you were to do that, then the public subnet would become a private subnet, right? So the internet gateway is the main thing here. This is the one that makes the subnet accessible. All right, now let's look at the network ACL. Remember, we said there's a second layer of firewall, right, at a network level. This is in addition to the security groups that we have seen so far, right? So this is a network level firewall, and it is attached to this subnet, which means it is protecting this subnet, right? And this works a little bit differently from the security group in that you have rules which are ordered, right? So you can have a rule 100, this is the default rule, and then another rule which is 101, 102. You can have jumps as well, right? So you can go from 100 to 110, 120, and so on. And the rules are evaluated in order, starting with the lowest number, right? And if that rule, if there's a match, let's say there's a network packet, and for that packet, one of the rules is a match, then no further rules are evaluated, right? So that's how the ACL works. It's a little bit different from the security group, where you don't have this ordering, right? The security groups don't have this ordering. This ordering is only in this ACL, right? So the way you normally do this is you have many rules, starting with some low number, and then the star rule here, the last one here, is the default rule. So if there's no rule that matches that network packet, then the default rule is applied, and the default rule is always to deny, right? So if there's no rule that allows, then that packet will be dropped, right? So this is how you set up your ACL, and if you look at this right now, right, basically this rule 100, right, rule 100 is essentially allowing everything, right? It's saying all traffic, all protocols, all ports, right? Any source, any IP address in the world, everything is allowed, right? So at this moment, this ACL is effectively not functioning, right? It doesn't stop anything at all, right? So what you need to do, especially in a live scenario, right, is you must edit this ACL, and you must remove, right? You must remove this rule 100, right? This rule has to be removed because it effectively allows all traffic, right? And in its place, you must create rules for specific ports, specific source IP addresses, etc. Right? But at the moment, let's keep it simple. We're not going to change this at the moment. We'll just leave it as it is, right? But know that this firewall is effectively non-functional. It's ineffective, right? It does nothing at all. All right. Okay. Now we have seen the subnet, right? We have seen the VPC. We've seen the subnet, and we've seen the route table associated with the subnet. We've seen the ACL as well, right? There are some other components. So there's an internet gateway here. You can see now there are two. One for the default VPC, and the one on the top here is for our scenario 1 VPC. Right? This is just a component. You either have it, you can delete it, you can detach it, but that's about it. There's no other configuration. It's a very simple thing. All right. Okay. So this is the internet gateway here. Right now we don't have a NAT gateway, we don't have a peering connection, etc. Right? This is all that is there. It's a very simple scenario, right? Let's look at this image again. Make sure that we have seen everything. So we've seen the VPC. Within the VPC, we've seen the subnet, right? The subnet is in a specific zone. It's in a specific zone. VPC is in the region, which is North Virginia, right? And we've seen that the subnet has a route table, right, which has a record for the internet gateway, right? We also see there's an internet gateway available for this VPC, right? And this lock here, that you see is the ACL, right? This is the ACL, and we've seen that as well. But right now this firewall is ineffective. All right. Okay. So now maybe we can take a break here. Right, we are approaching the midway point. We'll take a break here, and when we come back, what I'm going to show you is how to launch an EC2 instance in this VPC, in this public subnet. Right. We'll probably attach an elastic IP address, which is a public IP address, to this EC2 instance, and then we'll try and connect to this instance from the outside, from the internet. Right, over port 80, over port 22, and see that this works end to end. All right, but that's after the break. Let's take a short break and come back maybe in. So this is let's come back at 10 p.m. IST. Right, this is 10 p.m. IST. I'm sorry, I'm not converting it in any other zone here, right? Because I find this very hard, the conversion. So let me just write here. This is about 5 minutes from now. So let's get started. And before the break, we were looking at the scenario 1 VPC, right? And we're looking at implementing that scenario, which means we're creating the VPC, creating the resources in that VPC, right? Okay, now let me just answer this question here, and then I'll proceed with the demonstration. So Mukesh, in scenario 2 for the private network, why is there an entry for the NAT gateway in the route table, right? So this is scenario 2 here, and what we have here is a public and a private subnet, and Mukesh is referring to this table here, which is associated with the private subnet, right? And in this table, you have a record pointing to the NAT gateway, right? And the IP addresses is pointing to the external IP addresses, right? So this is 0000/0 refers to external IP addresses, the internet basically. And for that destination, you have a target of the NAT gateway. Right? So this is because the NAT gateway is used for outbound traffic to the internet from the private subnet, right? So the database server, for example, if it needed to download some security patches, right, it would need to connect to the internet, but only on the outbound side, right? You don't want to allow inbound traffic to connect to the database server, right? So for those kinds of use cases, you use the NAT gateway, right? And the route table is set up appropriately because it essentially is saying that external traffic will go via the NAT gateway, right? But the NAT gateway sits in the public subnet because it needs to connect to the internet, right? So NAT gateway is used by the private subnet but sits in the public subnet, right? Okay, so this allows this rule in the route table allows the servers in the private subnet to connect to the internet only on the outbound side, right? Only on the outbound side. Example for software patches, or rather, software updates, security patches, etc. All right. Okay. Now back to scenario one, and what we're doing is we have used the wizard to launch the VPC. We have the subnet, right? Now uh, we just need to launch an EC2 instance in this public subnet. Right? So let's go ahead and do that. But before that, right? Before I do that, what I'm going to do is I will create a security group. Right. So this will be a security group which will be created inside of the VPC, and then when we launch this EC2 instance, we'll associate the instance with this security group. Right. So let me do that, and then I'll go to EC2. So so what I'm going to do here is I will create a security group. Right. We'll create a new security group, and this will be in our VPC, in our scenario one VPC. Right. Let's just call this. Let's say this is scenario one web server. This is a web server security group. Right. So it's a very clear name, and let's create this security group here. Right. And we'll also create the rules for this security group. Essentially, we want access on port 80, right? We want access on port 80. So this is HTTP, right? This is HTTP, and we'll give access to the whole world, right? So anybody can access this web server on port 80, right? And we'll create another rule for SSH. And this time we'll only allow my IP address, right? It's safer this way. You should never have this one in port 22, right? So here I'm going to set up my IP address. I don't have a static public IP address, right? I'm just going to look at what is my IP address at the moment. This is my public IP address at the moment, right? This can change, especially if I restart my home router, right? But at the moment, this is my IP address, and I'm going to specify this IP address. And always you should add /32, right? /32 is the subnet mask for a single host, right? So you always say public IP /32 if you want to connect from your home network, right? If you're connecting from your corporate network, the mask may be different, right? It may be larger network. So you may have a whole IP address range, and for that the mask may be different, right? Okay, so now we have a security group allowing access on port 80 and on port 22, right? But it's at this moment there's no EC2 instance which is associated with this security group, right? We've just created the group at this moment in this VPC. All right, now we can go to EC2 and look at how do we launch an instance in this VPC. All right, so let me click on launch instance, right? This is something that we've seen before. So it's the same set of steps, and I'm selecting Ubuntu as usual, T2 micro as usual, and in this page, right, normally what we've done thus far in the course is that we've left this page alone, right? We've not really changed this too much, but today, right, because we are looking at VPCs, we'll have to look at this page a little more closely. So here, what we'll do is we'll select, this is the default VPC, right? Instead, we will select this one, which is our scenario one VPC here, right? So this is step one. Step two, we'll have to select our subnet. But this scenario, this VPC has only one subnet, right? So we don't really have to change this. This remains as is. All right. Okay. Now, in a VPC, there are no public IP addresses by default, right? So the default setting in a VPC is not to assign a public IP address, right? And this makes sense because a VPC is meant to be a private network, right? So you can enable this if you like, right? If you like, you can say you can override the default behavior and say that you do want a public IP address for this EC2 instance, right? You can change that, but by default, it's set to disabled. This server will not have a public IP address, right? I'm going to keep it at the default, right? And later maybe we'll assign an elastic IP address, which is also a public IP address, right? So for the moment, we'll keep it the same. All right. Now, one more thing I want to tell you is that in a private cloud, a real, going by the strictest definition of a private cloud, you have a dedicated equipment, right? You have dedicated resources. So the servers are only used by your company or your organization, right? So that's called dedicated tenancy. And normally, public cloud like AWS is all about shared tenancy. Right. So in the VPC, however, you do have an option of dedicated instances or hosts. There's a little bit of a difference between these two. You can look this up later. It's a detail I think we don't have to cover at this moment. But basically, inside of a VPC, you do have options of having dedicated resources, right? Which means it will not be shared by the physical host, right? Will not be shared by any other AWS customer, right? This will be more expensive, of course, right? This will be more expensive because there's no sharing, right? But in some industries, for some companies, right, this will make more sense. So this is an option. Very important thing here. You can choose to use dedicated instances, right? I'm going to stick to shared for the moment. All right, the rest of it is the same, right? This is the root EBS volume. This is the same. These are tags. You can set them now or later as well, right? We spoke about tags a little bit today. These are good for organizing your views, billing reports, IAM permissions, etc. All right. In the security group page, we will select the security group that we just created, right? Just a minute back. And this is the one which allows access on ports 80 and 22. All right. Okay. So this is a review page, and essentially, Ubuntu server micro, and it's in the VPC that we have just created. All right. Okay. So so you can see, the process is very similar, right? Thus far, we have created EC2 instances in the default VPC actually, right? And this is the first time that we're creating an EC2 instance in our own VPC, right? In a non-default VPC. All right. So once the server comes up, right? We will try and connect to it. But the main thing is you'll notice that there is no public IP address, right? There's no public IP address. This is the default behavior of EC2 instances inside of a VPC, right? And but it does have a private IP, right? It does have a private IP address, but this is useless as far as connecting to the server from the internet is, right? So I can't use this in my SSH client, right? Because it's a private IP. The internet does not know how to get to this server, right? Simply because it's a private IP. It's not a public IP address, right? Okay. So if you look at the scenario one picture here, what we have is we have launched this EC2 instance inside of this public subnet, right? And this EC2 instance also has a security group which does allow access from the outside world, right? But at this moment we don't have a public IP address, so we're not able to connect to this server, right? So what I'm going to do is I will allocate and then associate an elastic IP address, right? Anyways, we've seen in the previous module, especially in module 2, that an elastic IP address is more permanent, right? You should always use elastic IPs, especially in your DNS records, right? So it's so for a web server, an internet-facing web server, it makes sense to use elastic IP addresses. So that's what I'm going to do now, which is allocate first and then associate that IP address with this EC2 instance, right? After that, we'll try and connect to this EC2 instance. All right. So let me go here. Go to elastic IPs. Allocate, right? Allocate is simply requesting an elastic IP for your account, right? For your account, and then you can associate it to the server. Later, you can disassociate it from the server, associate it to some other server, right? The elastic IP can be moved around from one server to the other. But the first step is to request for an elastic IP. Make sure that you choose the VPC option here, right? Make sure you choose the VPC option, because basically AWS has two pools. It has two different pools. One pool is for classic EC2 outside of VPCs, and the other pool is for VPCs, right? So we'll choose VPC because our server is in a VPC. All right, so now we have one elastic IP available to us, right? It's not associated with any server at the moment. It's only available to us at an account level, right? If it is not associated like this, you will be charged, right? There'll be cost to allocating an EIP and not associating it to the server, right? So as soon as you can, you should associate, right? You should associate this to your server. All right, let me just try this again. All right, so here we are, right? And there's only one server running at this moment in this region. So we select that and we associate the elastic IP. Right? Okay, so it's done, right? It's done. And now this elastic IP is associated with our EC2 instance, which is in the public subnet of our VPC. Right? Okay. If you look at your instance now, you will see that there is a public IP and also an elastic IP. They're the same thing, right? They're the same thing because an elastic IP is also a public IP address, right? So I can now copy this public IP and I can connect to this server, right? I can connect to the server using this terminal window, which is my SSH client, right? If you're on a Windows computer, you must use something like PuTTY, right? So we will do. This is the private key that we have set up with this server, and this is the Ubuntu. This is the username for the server, and @ elastic IP address. Right? So we just connect in the usual way. We've done this in the past as well, and now we should be able to connect. Right, so here we are, right? This is the Ubuntu server. We have successfully connected to the server, and we can now, run our commands on this server. Right? For example, let me go ahead and install Apache web server, right? So that we can test the server on port 80 as well. So let me just update the repositories, and then we'll install the Apache web server. So what we do is we say apt-get install Apache 2, and that's it. It's, this step is very simple on Ubuntu, right? In some of the other Linux distributions, this is a little more difficult, but any moment now we should be this should be installed. Right. So what we'll do is now we'll test this on the web server as well, on the port 80 via the browser as well. Let me just wait for this to finish, and that's it. Right. That's it. Let me exit from the server, and now I'm going to try connecting to the server on port 80 via the browser. Right. So via the browser. And you can see that the web server responds, right? It responds with its default web page. You can try this as well. All right, and the same things, we can point our domain name to this IP address as usual, right? Let me go ahead and do that as well. I know we've seen this before, but sometimes it helps to show it again. So I'm going to, use Route 53, which is a DNS service, right? You don't have to use Route 53. You can use your existing DNS service to create such records. And essentially, what we need to do is point our domain to this elastic IP address. Right. So maybe I'll just edit one of the existing domains here. And I'll point this domain name, myapp.ws, paisaflow.com. This is just a dummy domain name, right? So my app will point to this elastic IP address, right? Okay, so we can now connect to our domain, which is this one, and sometimes it'll not work right away because DNS changes sometimes can take effect slowly, right? But some of you may see this, some of you may see this functioning. All right, so now it has worked for me, right? So you can see on the screen here that the domain is successfully being redirected to the elastic IP of that EC2 instance, right? So what we've seen here is really the full implementation of scenario 1. Right? This is the full implementation. You can see it's not that hard, right? Just have to understand a few things. Now, what is an internet gateway? What's a routing table? What are subnets? What's a VPC? Just a few things, right? Otherwise, the process of launching EC2 instances is just the same as before. All right. Okay. So let me stop here. Let's see if you have any questions, and then maybe I can also show you a little bit of scenario 2 as well, right? If you like, or we can also discuss. We can take stock, right? So we've seen a lot of stuff so far. EC2s, S3, EBS, VPCs. So we can discuss those topics as well. All right. Okay. So Tony, your question is: you can use apt-get to install software, right? Because the VPC has an internet gateway, and the answer is yes. Yes. Right? Yes, that's true. So the internet gateway is what makes the subnet a public subnet, right? And it's your gateway to the internet. Yes. So without the internet gateway, you would not be able to download the packages, right? You may, sometimes you're on the private subnet, right? You can use the NAT gateway to do the same thing, right? So you may be able to, what you can try this out. You can try this out, that if you're in the private subnet, right? In the private subnet, to download packages, right, or apt-get, or to use apt-get, you can go out to the internet via the NAT gateway as well, right? So it's possible to do the same thing on the private subnet as well. You can try it. I've not really tried it. You can try this. It should work, right? But yes, you need either the internet gateway or the NAT gateway to be able to use apt-get. All right. So what I'll do is, maybe I'll quickly show you scenario 2 as well, right? Because that's more common. And often you'll need a private subnet as well, right? Especially for your application servers, your database servers, etc. So let's look at scenario 2 as well, really quickly, and then we can do some more Q&A. All right, so scenario 2, right? This one here, where we have two subnets, right? We have two subnets, one private and one public. And what we'll do here is we'll have to install a database, right? We'll have to install a database server in the private subnet and a web server in the public subnet, right? And then the question becomes, how do we connect to the database server? If you want to access the database server from the outside, how do you connect? You don't have a VPN connection here, right? And also the web server needs to connect to the database server. So you need to make sure your firewall, your security group settings are such that this connection between these two servers is possible, right? So we'll discuss all this. But first, let me use the wizard once again and launch this time a scenario 2 VPC. All right, so what we do here is you go back to the dashboard, right? Always use the wizard. Don't try to do this by hand. And let's launch this wizard. And this time we'll create this one, scenario 2. All right. Okay, here, the wizard is very simple, right? It's the same thing. You have to come here and, give it a name and just go with the default settings. This is fine in most cases, right? So in this case, we have one public subnet and we have one private subnet, right? We have two subnets, both of the same size. You can see a subtle difference in the network addressing, right? This is 10.0.0.0/24. This is 10.0.1.0/24, right? So there's a difference in the IP addressing, but otherwise everything else is the same. One of these will be public, and the other one will be a private subnet, right? So now, however, this wizard needs for the NAT gateway, right? NAT gateway needs an elastic IP address, right? It needs an elastic IP address. So right now we don't have one. We don't have one. So I'm going to exit this wizard for a moment, create an elastic IP address, and then come back into this wizard. Let me just exit this for a moment, create an elastic or allocate an elastic IP address, right? I'm going to allocate a new elastic IP address, and we'll have to use this for the NAT gateway, right? So this is something that has to be done. So here's the second IP address that we now have, right? And now let me go back to the dashboard and launch the wizard, select scenario 2, and give this a name. And here in the elastic IP address for the NAT gateway, we'll select this one here, the new elastic IP, right? So that's about it. That's the only difference between the scenarios 1 and 2 as far as the wizard is concerned, right? And we just say create VPC. This one takes a bit of time, right? Compared to the first scenario, this one takes a bit of time because the NAT gateway has to be, I guess it has to be provisioned and deployed, right? So this will take a little bit of time. There seems to be some problem here. We'll try this again. We'll try this again once this exits. All right, let me just try and refresh this page. Let's see what happens. All right, let me try this once again. All right, so this time I think it'll work fine, and it'll take a bit of time at this step where the NAT gateway has to be created. Right, so this may take a couple of minutes, and then we'll have our VPC set up. So what I'm going to do next, once this VPC is up, is we'll inspect it. Right, we'll inspect it. We'll look at the two subnets. We'll look at the two route tables. Right, one will have the internet gateway, right, which means this one is the public subnet. The other one will have a NAT gateway in one of the routing rules, which means this is the private subnet using the NAT for outbound traffic, right? So we'll inspect all this a little bit, and then we'll create two security groups, one for the web servers and the other one for the database servers, and then we'll launch EC2 instances, one in the public subnet, one in the private subnet, right? So okay, and let me also tell you one more thing, right? That normally, you would install RDS instances, right? RDS is the relational database service. We'll see that next week, right? We'll see that next week. And what happens is with RDS instances, RDS needs two private subnets, right? Because it has this multi-AZ capability where you have a primary and a secondary server with replication, right? So RDS needs two private subnets. So what you need to do to have RDS is once you have your scenario to VPC created, you need to go and create a third subnet, right? And this is also a private subnet. And once you create the third subnet, you can then launch RDS. This is just a pointer to you if you are creating RDS instances at some point in scenario 2, right? You need to create a second private subnet. All right, let's look at this. I think it's been created. Let's inspect our scenario 2 VPC. Right, so this is the one. This is the one, and you can see the IP addressing. Right, it's the same. Scenario 2 has the same IP addressing as scenario 1 here. Right, and this is okay. This is okay because both of these are private networks. Right, they don't talk to each other, so there's no conflict. Right, there's no conflict. So this is fine. All right. Now in this in the subnets, right? In the subnets, now we'll have two more. You'll have two more subnets. This is the one which is the private subnet of scenario 2, and this is the one which is the public subnet, right? And both these subnets, right, are created in zone 1D at the moment. It's not necessary to have that, right? You don't have to have them in the same availability zone. You can have them in different zones as well. That's not a problem. And if you look at the route tables, you can see the public subnet has the internet gateway mentioned, right? And the private subnet has the NAT gateway mentioned. Right? This is as expected, right? You can see here, public subnet should have the internet gateway, private subnet should have the NAT gateway, right? So this is what we are seeing here as well, right? And you can also find these things in the other menu options. So if you want to go to the NAT gateway section, you can see there's a NAT gateway here, right? And this is the one that is associated with the private subnet. And like the internet gateway, it's a very simple component, right? You can only create and delete. There's no other configuration that needs to be done here. All right. Okay. So that's it. That's it. It's very simple. The internet gateway is there, right? There'll be more internet gateways now. This is the one that is for scenario. This is the one for scenario 2, right? So we also have our internet gateway. We have a NAT gateway. We have two subnets, one public, one private, right? It's all set up properly, right? And it's very simple if you use the wizard. All right. Okay. Now what we want to do is we want to essentially create a database server. I'm going to launch EC2 today, right? Not an RDS instance. We'll see that some other time. But I'm going to launch an EC2 instance on which we can install our database, and we'll launch this instance in the private subnet, right? In the private subnet, right? But before we do that, we'll have to create a security group for the database server, right? Let me do that first, and then I'll launch an EC2 instance. So what I'm going to do is in the VPC control panel, go to security groups here and create a security group called scenario 2 DB server SG, right? This is the security group for the database server, and we'll have to specify our VPC here, which is scenario 2. All right, so this is our database server security group. And the inbound rules, right? What should be the inbound rules? So normally what you would do is you want to allow traffic on, say, a database port, right? Let's say if you're running MySQL, right? If you're running MySQL, you would use port 3306, right? This is the default MySQL port. If you're running something else, maybe Microsoft SQL Server, then the port would be 1433, right? These are default ports of these databases, right? So it depends on what you're running on the database server. So So this is one, right? This is one, and now the question also is, what is the source? What is the source for this database server? Right? That's an important question. If you look at scenario 2 here, right, what you really want is these web servers to be able to connect to the database servers. That's all you want. There's no need for anybody to connect from the outside, from the internet, right? Anyways, nobody can connect to this server because it's in the private subnet, right? What you want is to allow only these web servers to connect to this database server, right? Now, the problem is you may have many web servers here. You may have an auto-scaling group, for example. So you can't really specify an IP address because there could be many IP addresses. Those IP addresses may change, right? Although private IP addresses don't change, right? So you can set up IP addresses, but you don't want to hard code IP addresses because the servers, there will be sometimes more servers, sometimes less servers. So you need a better way, right? So what you can do is in your security group, the source IP address, instead of being IP addresses of your web servers, can be the security group ID of your web servers, right? So you'll have a security group here for the web servers. So the ID of that security group can be the source for your database security group. This is very important to know, right? So what I'm trying to say here is in the inbound rules of your database security group, instead of specifying the IP addresses of the web servers here, you can specify the security group ID of your web server security group, right? So this is very important. But we can't do that now because we don't have a web server security group. So that's why let me go ahead and create a new security group. This is for the scenario 2 web server security group, right? So this is the web server of scenario 2. All right. So okay. Now in the database server security group, we can now create an inbound rule where we say, fine, we are running a Microsoft SQL Server here. Maybe we're running MySQL, and we want to allow traffic from the web server security group of this VPC. Right, so I'm going to select this ID here, right? So note that I don't have any IP address here, right? I don't have IP address here. I have a security group ID, which is a great solution because I don't have to hard code any IP addresses, right? I can have tomorrow I may have more servers, and I don't have to come and change the security group when I add new servers because this one entry here will function just fine, right? This is very important. All right. So now we have a database security group which allows traffic from the web server security group, and all we need to do now is to launch a database server in the private subnet, right? So let's go ahead and do that. So I'm going to launch an EC2 instance, right? Maybe this can be an Ubuntu server as well. It doesn't matter. And here in this page, right, we'll have to select VPC as scenario 2, and we'll have to make sure that our subnet is properly selected, right? So we want this server to be a database server, therefore it goes into the private subnet, right? It'll go into the private subnet, right? And because it's in the private subnet, there's no sense in having a public IP address, right? It doesn't make any sense. Everything in the private subnet will only have private IP addresses, right? That's it. So now we can move forward. All these selections are something that you're familiar with. Here we are selecting the database server security group that we just created, right? This is important here, and we can now review and launch. All right, now if you were to connect to the server on SSH, we'll use the same demo key, right? So All right. So now this is a server. This is a server which is in the private subnet. It's in the private subnet of our VPC, right? And there's no public IP. There's only a private IP, right? There's no way anybody can connect to this server from the internet, right? It's very, very safe. It's very safe. All right. Okay. Now the question is, how will you connect to it, right? Let's say you want to do some action on this. You want to maybe install a database, import some data, right? How will you connect to this, right? How will you connect to this? So the only way to connect to this is to connect to the public subnet, right? Use SSH from the internet, connect to the public subnet on this web server, one of the web servers, and from there connect to the database. Right? That's the only way in which you can access the database server, right? And that you can practice that yourself, right? Try and essentially this server is right now an EC2 instance. It doesn't even have a database right now, right? So this is, you need to connect over SSH, install the database, etc. But normally you would create an RDS instance, right, which has the database already installed. You can open up the port on the database port, MySQL 3306, for example, and then from the EC2 instance, connect to RDS and create your database, import some data. So all those operations are possible from the EC2 instance, right? But today I think we'll not see that. But I hope it's clear, right? I hope it's clear. All right, let me stop here. Let me know. Please let me know if you have any questions. We have about 45 minutes more, right? We can spend some time on VPCs. We can spend some time on Direct Connect, which is another networking service, and then we can also spend some time looking, back at the previous modules and see if you need any help with, especially with the practice aspects, right? Are you able to connect to EC2 instances? Right? Are you able to use the CLI, for example? So we can discuss those things. All right. So Ratish, what you're saying is, can we create a second VPC and look at creating a peering connection, right? That's the right term, right? So you're looking for a peering connection, right? And I'll show you this, right? I'll try and show this to you, but also remember, right? There should be a good reason for connecting them. Right? Normally, VPCs are meant to be isolated networks, right? There should be a good reason why you are connecting them, right? But otherwise, we'll take a look at this, how to create a peering connection. Let me just answer some of the other questions here, and then maybe we'll look at creating a peering connection. All right. Okay. So Ratish, I think, yeah. So maybe I misunderstood your question, right? Maybe what you're asking for is a VPN connection, right? What you're asking about is a VPN connection. I'm not sure I'll be able to show this to you because you need a VPN client, right? And I'm not, prepared to show that to you today. Maybe some other day, right? Maybe some other day. So what you're looking for is a VPN connection, which is essentially connecting your corporate network to the VPC, right? Using VPN, which is basically an encryption, of your communication between the two networks, right? So this needs a VPN client, and I need to do a little bit of preparation to show this to you properly, right? So I won't be able to show this to you today. Maybe we can do this at a later date, right? So this makes sense. Yeah, peering is something that you need to do with some specific use case in mind, but VPN connections are common, right? Especially the scenarios 3 and 4, right? These are basically the scenarios 3 and 4 in the documentation and in the wizard, right? So this makes a lot of sense in many use cases. And yes, this is also good for hybrid environments. Yes, this is required for hybrid environments. Yes. All right. Greg, on the security rules table, is the order important? Can we change the order if required? So on the remember that there are two, right? There are two firewalls here. One is the network ACL, right? And the other one is the security group. We are more familiar with security groups because we've seen this in the previous modules as well, right? And here in the security groups, the order is not important. Right? Order is not important. In fact, there's no order here. Right? There's no order. There's no number which gives it an order. Right? So you can create as many rules as you want. There's no order here. Right? However, in the ACLs, there is the order is more important. Right? So here, for example, if you look at this, the inbound rules here, you can see there's a rule 100, right? You can create a rule 101, 102, 120, 130, and there the order will be important, right? So each rule is, the packet is evaluated against the lowest number, the rule with the lowest number first, and if it does not match, it goes to the next number in order. And if there's a match, it evaluates no further rules, right? So it's only one rule will apply to a network packet, right? That's how this works. However, the security group is different. It doesn't follow any order. All the rules are evaluated, and the most restrictive rule will apply, right? There'll be some logic, some algorithm to determine how that packet is treated, considering all the rules that are available in the security group, right? So let me just write this here. So SGs, no order, right? No order. All rules are evaluated together, right, to decide what happens to the packet, right? Whereas the ACL, or rather the network ACL that we have, there are ordered set of rules, right? Rules are evaluated starting with the lowest number, and rule evaluation stops as soon as one rule matches the packet, right? So they just work in a different fashion. You can change and you can change the order, right? You can change the order in the case of NACL. Right? You can change the order by changing the number, right? By changing the number, for example, you can change rule 100 to say rule 200, right? Something like this. All right, so this question here, Paul, what is the use of the endpoints, right? So this is a good question. You might have noticed this is in one of the screens here while we were creating the VPC, right? So just for the benefit of others, right? Let me show you when you were creating this scenario 2 in the wizard, right? There's this option here called service endpoints. So this is essentially what these are is that normally within a VPC, right, your network stays within a VPC. Now there are certain services like S3, right, like S3, which may be outside of the VPC, right? They may be outside of the VPC. You may have buckets which are in S3, which are outside of your VPC. And what this endpoint will do is create like a connectivity, right, from your. These are basically virtual devices, as AWS calls them, the endpoints. These are virtual devices which allow you to access S3 from your VPC without going to the internet, right? Without going to the internet. So that's what these are. All right, so the endpoints are virtual devices that allow connectivity to S3 essentially from your VPC without having to go to the internet. So it's an internal, within AWS. connectivity to stuff which is outside of your VPC. And also, we can look at the documentation. I'm looking at the documentation on another computer here. Basically, it says without having to use to go to the internet, without having to use the NAT service, NAT gateway, right, or a VPN connection, right. So you don't need any of these to be able to connect to S3 if you use the service report. All right, so this question here from Mukesh is, why did we assign a public IP to the NAT gateway, right? So this is this is what we did, right? When we created the scenario 2 using the wizard, we went out of the wizard, created an elastic IP address, and then in the wizard we specified that elastic IP address to be associated with the NAT gateway, right? So that's the question that Mukesh is asking, and basically what happens is the NAT, right? The NAT is network address translation, right? What it is doing is it's when the traffic goes out from the VPC to the internet, right? There's a target, right? The public IP address or the elastic IP address is what becomes visible to the destination, right? To the destination, and that's how the the stuff can be downloaded, because that public IP address is available for the destinations to communicate with, right? So essentially, what the NAT does is it translates, right? It translates your database server's private IP into the elastic IP address, right? So right, and this basically enables the software patches or whatever you're trying to do, right, through the NAT. This enables the software patches to be downloaded from the internet. All right, folks, let me know if you have any other questions, either on VPC or we can also talk about some of the stuff that we've seen in the earlier modules, right? So yesterday, for example, EPS, S3, Glacier, all these are very important services. And prior to that, we also looked at EC2, right? EC2 instances, things like armies, security groups, keys, public-private keys. I hope you're all, you're practicing, right? You're able to. You have an AWS account, and you are maybe practicing the demonstrations that I am showing you, or you're looking at the assignments and labs that are available on the learning management system, right? I hope you're practicing, and if you're facing any problems, right? For example, Greg mentioned that he faced some problems setting up WordPress on a Windows server, right? So if you're facing any of those problems, right? We can help you there, right? Because often, for example, right, people face problems in connecting using putty, right? Maybe that's where you're stuck. So so if there are any questions of that kind, please let me know. We have about half an hour, right? So I think it makes sense to discuss those kinds of questions as well. All right, so this question here, Greg, what you're asking is, are there practice exams? I'm sorry, practice exams on the Edureka website. So what we have right now is we have these these quizzes are available under each module, right? So this is what is available, and then there are labs that you've been doing already, right? So this is what is available at the moment. Now let me just tell you, this AWS certification exam, right? It's a very well designed exam, right? And those questions and those options that are available under each question, they're very carefully, the whole exam creation is a very big effort, right? They create thousands of items, and those are tested vigorously. And so the test is a very high quality test, with the purpose of separating people who really know, right, this AWS from the others who don't. Now these questions cannot be of, let me be frank, right? These questions cannot be of that level or that quality, right? So these questions are good. They're good. They'll force you to think about what you're learning, right? But they're not. They should not be considered equivalent to the examination questions, right? So that's one. But these are good for practice. And also in the presentations, right? In this presentation, for example, there are some in the end, in the last few slides in each presentation, there are some good questions. For example, these questions here, right, which we've seen sometimes, and there's also some of these interview questions. Right, this is something that the Edureka content team has gathered, right, from the market. So these are some questions you can look at as well, right? So this is what is available right now. And what I suggest you do is AWS also has a mock test available. Right? So that's something that you can take as well in your preparation. Right? So these are the options that I know. So on with Edureka, what you have is with Edureka on the LMS, you have a quiz. I think these are like 10 questions per module, and there's also some interview questions in the slides, right? In the slides, but these questions are not as good as or not similar to the AWS certification exam, right? So for this, what I recommend is try and look at the mock exam. Right, the mock exam. This is also proctored. You have to go to a center and well, not proctored, but you have to go to a center, I think, to sort of take this exam. And I think the cost is about $20. Right? So you can. This is good. I recommend you do this before you actually go and take the main exam, right? And there are some sample questions available on the AWS site as well. So let me show that to you. You might have seen this, but let me show this to everybody in any case. So just go to the AWS Certification Center, and here in this page here for the Solutions Architect Associate Level Certification, right? You can see here on the right side, there's the exam guide, and then this is the sample questions, right? And this is the practice exam, the mock exam. Right? You can click on this and schedule an exam date, right? So let me just give you the link to this as well. All right. So Ratish, you're asking, are we going to cover the Lambda function? Yes, we'll do that. It's in the scope in one of the modules. I think module 7 or 8, right? So we'll look at Lambda. Which is a good, very good service, right? It's basically a new service where you don't need servers to perform to execute some programs. Right? So it's a good service. We'll cover that. We'll spend some time on Lambda. Yes. All right. So if there are no more questions, right? Let me cover one more service. Right? We have some time. Let me cover one more service. It's not very important, right? Most people, I think, will not need this right away. But this is, what we're trying to do here in the course is talk a little bit about, spend a little bit of time on enterprise services as well, right? Services which are important for larger companies, for enterprises. So let me talk a little bit about the Direct Connect service. Right? This is one of the networking services that is available along with VPCs and Route 53. All right, so this is a quick word about Direct Connect. So what this is it's a leased line, if you will, right? It's a direct connection from your corporate network to the AWS cloud, right? and it has very high speeds, 1 gigabit or 10 gigabit right? There are two options. You can also go for multiple connections to have even faster connections, right? It's available only, I think, in a few cities around the world, and sometimes you may need a service partner to take care of the last mile, right? The last mile from your corporate network to the AWS termination point in your city, right? But once you have this direct connect established, you have a dedicated connection bypassing the internet, right? Bypassing the internet, and you can essentially send and receive data over this network, right? And the benefits are you can basically connect to all the services that we are looking at, right? EC2, S3, Glacier, etc. over this direct connect. Right? This is what it is, and the benefits are you can set up. It can be more secure. You can use VPNs as well with direct connect. And the main thing is it can potentially reduce your bandwidth cost, right? So this may be cheaper. You have to do a proper evaluation to make sure that it is indeed cheaper than your existing internet connection. But also, a direct connect will give you consistent network performance. And the reason is, if you were to use your own internet connection, right, which has other uses as well, the same connection is being used by your employees for regular email and other applications, right? So there will be a contention. So your data transfer for your infrastructural needs will contend with regular end user network traffic, right? So you may not get consistent network performance because of that. And also, the internet itself is not a consistent network, right? So the internet, the route that the network packets take keeps changing on the internet, right? So the internet does not give you consistent performance, right? And that's by definition. But this one, the direct connect, can give you consistent network performance. So there are certain use cases where you need that, where you need consistent network performance. So that's one reason to use direct connect. All right. Okay. So this is broadly it, and then these are some pricing, some pricing information. It depends on the speed, the port speed, and I think those, the 1 gigabit and 10 gigabit options can be divided into these speeds. Your direct connect implementation partner can give you these speeds, right? So the lowest speed starts at about 3 cents per hour, as you can see in this slide here. All right. Okay. So I think that's about it. That brings me to the end of this module here. And what we're seeing today is basically VPCs, right? Basically VPCs, and within VPCs, the subnets, public and private, and all the various components: Internet gateway, routing tables, NAT gateway, etc. All right. So any questions, right? Any questions on Direct Connect? Please let me know. And if not, I think we'll end the session early as well. Right? That's not a problem. And next week we need to look at databases and autoscaling and load balancers. All right, folks. So looks like there are no further questions, right, for today. So let's end the session, right? We'll end the session now, and I'll see you next week for the other modules. All right. So thanks for joining. Have a good week. See you later.